Hello, in my last video, I showed this project and why it wasn't working and some of the changes I wanted to make. And so one of the first corrections is I unsoldered this off the board, put this piece of capped on tape. So this yellowish area is just tape, help insulate this lead from this ground line. And with the multimeter, I confirmed that they were no longer shorted. So that was this output shorted to ground. The other thing I changed was this diode was reversed, so I unsoldered it, stuck in a new one in the correct orientation, and I thought that was it. But when I went to test it, it still wasn't working, and I spent a lot of time trying to figure out if there was another short circuit or what was wrong. Did the microphone fail or did the chip itself fail? But in the end, I realized I had mixed these two up. The inverting and the non-inverting. So I had these connections here backwards where these were all connected here and the inverting input was connected to ground. So now that I fixed that, I want to show you how it is working. So the other thing I talked about changing some of the resistors, but before I do that, I haven't done it yet. Let me show you this. So here, this is a 5-volt power supply. I used it in my last video. So let me turn that on. And then let me turn this on. And there we go. So we have one LED going, and it's not showing up on the video so well, but there are several LEDs that do light up depending on intensity of the sound. What I do notice, though, it's very hard to get up very high, and so that has to do with this resistor ladder here. The other thing too is that they don't stay on very long, and so if you remember, this was the envelope follower, and I had changed the original circuit and added these two because of what I found on my breadboard. But I think, yeah, this is definitely, the resistance is too low. These two resistors here are draining the capacitor quite quickly. I think that's what's happening. And so then my VU meter, I want the LEDs to stay on a little bit longer. So I think I need to change this here. So the other thing is, when I was trying to figure out, well, why it wasn't working, why this part wasn't working, I added another signal here. I tried this module. It's a microphone module too. And I was measuring voltages, and it got me thinking that this setup here could be better um, with the resistors at this end. And of course, I talked about this end last video. So coming back to the computer here, these are the resistors that are on there for that resistor ladder. If that doesn't make sense, please look at the last video. But I think what I want to do is take the first two fixed resistors and actually just remove them entirely. And then for my two potentiometers here, I think I'm going to take one out and put in a really big one. So this is 10,000 ohms. I think I'm going to put in 100,000 ohms. Maybe keep this one in. So one is a coarse measurement, or coarse change, and then this one would be a more finer change to get a little bit more control of the thresholds at the higher end. And then, as I said in the previous video, change this. I think actually I'm going to put a fixed resistor between the potentiometer and ground, something like that. And like I said, make this closer to 100,000. So then I can get my upper thresholds, or all of the thresholds really, but upper threshold quite low, because a lot of times with these electret microphone signals, they don't even get up to 1 volt. So if I want to take advantage of all the LEDs, then I need to lower the thresholds. And then, like I said, I can get quite low. So if I want something really high. So getting up close to the maximum voltage, then getting rid of those first two resistors and changing this potentiometer, I would have much more control over the thresholds. Like I said, this is not a rail-to-rail op amp. That's why I started with these, but if I'm going to have the ability to add another signal, then maybe that signal could be more rail-to-rail. So I would like to change those. So now that this is working, fixing this circuit here, I'd like to make some adjustments here, get rid of these two, change this potentiometer, and to maybe have this voltage follower adjustable. I think I'm going to remove these two resistors, maybe move this potentiometer actually in place of those, so then I can change how long the duration is for these LED lights. So let me make those changes right now. Hello, I'm back. So that part you just saw, I filmed about 2 months ago, and it was really right after the first video, part 1, and this is part 2, obviously. But when I went to make the changes on this board, I didn't have this version of potentiometer in the values that I was actually looking for. And the local store didn't have them, and I ordered them online, and they still haven't arrived yet. And now there's a strike here in Canada, a postal strike, so who knows when they're going to arrive. But I had gone back to the store, and I did find some, so I tried to make do with what I had. So let me show you what I have. So I'm going to put up the schematic of what I have at this moment. I still think there's room to tinker. But then if I show you here, this is the upper half. It's a Fritzing. It's a schematic from Fritzing. So the version of Fritzing I have, the LM358 is actually stacked vertically rather than horizontally. So that really changed how I laid things out. But I think you could see, so 5 volts would be the coming from the wires, and then there's the switch and the jumper. So there's a switch and the jumper, right, allowing me to separate the powering the top half from the bottom half. The microphone is here. Okay, here's VCC1, which is that part of the jumper. So how I can, if I remove the jumper here, I separate powering from the battery to that side. What can I show you? Oh yeah, so I I meant to put this as 1,000. So currently this is 2,000. If you look, it says 202. So 20 followed by 2 zeros for 2,000. But I think even that probably should be lower, like 500. Like right now, this is a good position, but you can see it's turned almost all the way. You know, it's like 3/4 of the way to the side. About 200 ohms right now. Seems to work well. Let me show you the other half. So this is the bottom half of the board, like sort of here down. Not this obviously, but here down. And the 100 kilo ohm potentiometer, and the 10 kilo ohm potentiometer, and the rest of the ladder. So if this confuses you, please have a look at the last video. I guess what's not on here, one thing that's not on here on either is the top or the bottom. These are 100 nanofarad capacitors that go between VCC and ground for each IC. So here, okay, there it is there. I should have put those in just to be complete, but when I was trying to not make this too complex, I guess I didn't make it in. So let me show you how it works. So here's my 5-volt breadboard power supply again, and I will plug in ground and power. So this is off, this is off. So let's turn this on. There's a green LED to show it's on, and then there we go. So if I lower my head a little bit, you can see that the VU meter is actually working pretty good. Like that's really what I wanted it to do. After getting it to this point, I realized that some of these could be much different. So, like I said, this capacitor could probably be a smaller, like a 500, or sorry, potentiometer could be a 500. This is cranked up all the way right now, and the two of these, to get it to do what I want right now, like otherwise very few of the LEDs light up, and this one is actually cranked down quite low. So even though these may not be ideal, this is actually kind of where I want things, you know, how I want it to work. So I guess you could say that this is working, although this could be better. So for the rest of this video, I actually wanted to show you like how accurate these are. You know, were the corrections on the Excel accurate, or how accurate are they compared to what I can measure with my multimeter? And then I also have been reading up on op amps, and in a book, which I'll put up on the screen here, that kind of talks about this circuit here, about isolation and like the filtering that's actually happening here. So let me go through those. So first, let me talk about the Excel file. Okay, so if we go to the computer, so I showed you something like this last time, and this was what I used basically as a starting point. And so I had different resistors. So these are the resistors that I wanted to put for my resistor ladder. But of course, you know, there is tolerance to resistors, and they aren't going to be exactly what you intended. So this column here has actual values. And so let me just show you a couple things there. So first of all, let me turn this off here. Here's my multimeter, and I'm going to turn it to resistance. So you can see it's in, well, ohms or kilo ohms or mega ohms. If I just, here are the two leads, if I just connect them together. So yeah, a couple of ohms, it's not too bad. So one thing I want to show you is, so this, where are we here? So this potentiometer only has two of the connections connected, and same with this one here. So that's this one here. So if I go from the top pin there, then I'm connected basically here. This one is not connected. So that's, this side here is not connected, but this side here is connected to the wiper of the second one here. And then likewise, this bottom is this bottom left. So if I try to click on that, and they're both, I mean, essentially cranked up. This is kind of my way here. They're both essentially cranked up all the way, but it's only reading like under 20 kilo ohms, but it should be reading well over 100. And that kind of threw me for a bit. So I keep touching it so it keeps moving around. But that's all over the place. It's like, yeah, there's about like 19 kilo ohm, right? 19,000 instead of over 100. And the reason for that, it took me a while to figure that out, is because this jumper here. So this, if I move this out of the way here, so I'm trying to measure across these two, but it's still connected to VCC2, which is, if I go back, so VCC2 on the top part is here, but with the jumper it's connected to VCC1, which is connected here to these two resistors, which is connected to ground. But everything's connected to ground, including, for example, this ground through this resistor and that potentiometer, and all of these resistors right back to this end. So although I have the probes on either side here, it's measuring through this, but it's also measuring through the whole circuit. So long story short, you have to kind of, if it doesn't make sense, you have to kind of think about what are all the connections. That fell off. So if I remove this, if I can get it all in one screen, or all on the screen, if I remove this red jumper here, then yeah, it's kind of close to 110,000, which would make sense. Okay, so it's 106,000. Make sure 106,000 and 900. So let me actually put that in here. So into my 106,900. That's sort of the accuracy I can get here. And I won't go through all of these, but I will just kind of show you. When I made this, I put a lot of sort of loops for test points. So like I said, here's ground. This one, there's one here if I wanted to hook onto, to measure VCC. But here, this is the first resistor there. So it's connected between here and here. And then I just have to come down here to measure the value of this resistor. So if I just kind of poke this down, let's move this over so you can see it. Poking this down. So 997. So, or sorry, 9.97. So 9,970 is what that's reading. So if I just kind of 9.98. So that's what I had before, 9.98. And so I did that for all of these. Okay, this bottom resistor here is, or this one here is, this potentiometer is probably easier just to measure off the bottom here. So this is the top and this is the bottom of it. It's right here. So 2.6. So it's like, so you can see it's cranked all the way to one side. It's basically totally connected because it's about the same as if I connected these two together. So basically no resistance there. It's connected. All right, 2.5. So I'm going to put 2.5, but really it's probably about 0. Okay, so we can go up as high as 2,000, but really it's like 2.5 right now. So the Excel sheet was to be able to measure what the voltages are on my voltage ladder. So let me turn the power back on here and switch this to voltage. Okay. And is it working? Oh, this is the red jumper's not connected. It's not working. Doesn't have power. Okay, so now it works again, so you can see that. But if I connect here to ground, so this jumper male pin there is ground. And so if I connect here with this loop, then this should be the voltage. So it's supposed to be 5 volts from the power supply. It does move around a lot, but so at the moment it says 4.969. So we'll put that in to the Excel. 4.969. So now in the green here, these are what the value should be at for each section of that resistor ladder. So if I go to the first one, which is this loop here, which is again between this potentiometer and this first. So this says 0.808. And our spreadsheet says 0.81. So that's actually quite close. It's actually quite good. The next one here says, so it says 419.6 or 0.4196, right? Because it's ranging there. Yeah, so the Excel spreadsheet says 0.42. All right, so that's actually pretty good, I'd say. The other thing I added that wasn't on the previous version is I added another loop here. This loop is actually the signal coming in for so this blue wire going to all of the input. So input 1. So that is a way of measuring that input 1. So you can see if I talk closer to the microphone, you can see that the voltage is going up and down with changes in the sound of my voice. Okay. So I do notice sometimes some of the LEDs will stay lit. I'm not exactly sure. I guess that might have to do with this potentiometer, because if I turn the resistance up more, sometimes like 1 or 2 or 3 will stay lit. I guess it also depends on what the resistance is at either end. When it does do that, I see that if I give another strong sound and another strong signal, it often will eliminate and go back to 0 and turn that one off. But so like there, it does sometimes linger. So it's not perfect, but it does seem to be working pretty good right now. Okay, so the last couple things, if you're wanting to make this, that I want to show you is something actually, I guess, kind of based on theory, based on this book that I read, was about this part right here. Well, so it's about inverting amplifiers. And when I was reading up on this circuit, so my understanding was this capacitor here will block the DC portion, right? The steady voltage, and only what changes when the sound waves, cause fluctuations. And it's those fluctuations that you want to come into your circuit. But there's also a capacitor here. And so these two capacitors kind of isolate this from the rest of the circuit. The book talks about how this point here is the DC point. So here, this is between the two resistors, and they're both the same. So this is half of VCC, which is 5 volts in my case, so about 2.5 volts. And so then having these two capacitors will sort of isolate this DC point of this part of the circuit from the rest of the circuit. That's not so critical in this project, because I'm not trying to get exact values. I'm just trying to get the fluctuations. But if you are using, if you're trying to learn about op amps and trying to make something accurate, these actually, what they do is they help isolate if there's an offset between these. So if you know about op amps, this inverting side, if it's higher, will make the output lower, whereas the non-inverting side will make it higher. If they're both the same, then I think this should be positive, or like if it's open, it would go positive. If this is just a tiny bit higher, then this should go lower or low. Okay, but if there's some offset here, maybe it has to be quite a bit higher, or way more than what you would expect if these were both equal for the inputs to have the effect that you expect here. And so by isolating these, then you kind of isolate that error, even if the rest of the circuit, whatever it is, like you can kind of ignore this, but whatever the rest of the circuit is, using other op amps, even if they're also working at 2.5 volts, these kind of help to isolate sort of that error, and propagating it through when you're trying to amplify it, for example, 100 times, then your error would be amplified as your signal goes from one part to the next part to the next part. So anyways, I thought that was very interesting. The other thing that the book talks about is these two components here act as a high pass filter to the to your amplifier. So you're trying to amplify this, but actually this might be dampening your signal. And so assuming then, from what I gather then, is if that's true, then if you think about, let me zoom out here, high pass filters. So if this is your signal, and it's fluctuating. And here's ground, so 0 volts. And this is some sort of positive volt. And if you have a capacitor here, and your output to, in this case, to our op amp, and you have a resistor here, again, this is your ground, okay, and this is to ground, then this is a high-pass filter, and so it will actually reduce the output of lower frequency signals and allow higher frequency signals to go through. And in fact, like a Bode plot, where this is in decibels and this is in frequency, so like hertz, but it's a logarithmic, you can, there's a kind of graph like this where this is 0 decibel, meaning it's not, your signal is not being reduced, but below it, it is being reduced. Whatever frequency your signal is at is being reduced somehow. And so like there is this point here, this cutoff, right, at a certain frequency, so we call it F of C, and it's about like 70.7% of whatever your, I guess, your signal is. And actually you can calculate what that is, and it's, the formula is like 1/2 times pi times the resistance times the capacitance, right, your capacitor and your resistor. So like in our example here, 10 microfarad in 1000 ohms, so 2 times pi times 1000 ohms, and then you have to multiply by 0.00001 farads is the same as 10 microfarads. So like this comes out to something like the F of C is like 15 or 16 hertz or so, meaning that it's blocked like, I guess, what, 30% at that frequency. And so the book suggests that whatever signal you're interested in should be, this should be 100 times lower than that. So, and then I Googled like a human voice, at least like a male voice, because I'm male, is something like 90 to 155 hertz. So I don't know if I'm like in the middle in there somewhere, something like that. I don't know what my frequency is, but not the deepest, not the highest. So like this is not 100 times lower than that. So all of that to say, maybe, although I'm trying to amplify 100 times here with these two resistors, this combination might be actually reducing it. And so I was actually playing with recording and my voice, and I don't know if you want to see that, but I was trying to look at this and make a recording of my voice and increase the pitch and see if that affected this. It does look like it kind of has an effect. So, and I guess that makes sense since we're talking like, 30% or, whatever, 20% or something reduction. So anyways, I thought that was interesting. So if you watch the last video, I got this circuit off the internet, and maybe that's good for certain sounds, but if you're trying to use it to measure your own voice to see if you're speaking loud enough, which I kind of thought maybe I'll see if this would help with that, then maybe the combination of this capacitor and this resistor could be a little better to target the frequency of my own voice. So anyways, I guess that's something to think about. And, if you're trying to perfect this and make it yourself, then maybe you do want to tinker with these. You certainly don't want to go to any extremes, because, then you sort of run into other problems, but that might be something you would look at. So anyways, I hope you found this interesting. Certainly I, did learn about op amps, and it was kind of a fun project, and it is actually working. So that's always cool. I think I do want to do another video. I tried to make knobs for these. So maybe I'll make a video about that and stick them online. There weren't too many that fit this kind of potentiometer. So you could look forward to that in my next video. Anyways, thank you for watching this, and I hope you learned something. If you do make this circuit, send me a message. I'd love to see what you've put together. All right, thanks.